Hi everyone and welcome back to my channel AA Economist. So in the previous video, we have started off with multiple linear regression model. Today we'll be continuing that and we will know the concept of multiple and partial correlation in the context of multiple linear regression model, right? So this is going to be a concept video. I'll be explaining with a particular example what is the concept of multiple correlation and what is the concept of partial correlation and intuitively how you can think of this, right? This is going to be our lecture number 21. And now let's start with the model. So the model that we will use for our discussion will be something like this. Yi is beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x3i plus some stochastic error term, which is ui, right? So this is going to be our model. Now, in this model, we will assume that this yi, the dependent variable yi, will be measuring the yield of crop. Yield of crop. So basically, we are taking a particular example, right? Particular situation. So yi, suppose this is the dependent variable which measures the yield of crop. Here, x1i is the first explanatory variable. Suppose this measures HYV seed. HYV seeds that we use in the production, right? That is high yielding varieties of seeds that we use in the production. So HYV seeds has some effect on the yield of crop. Now let's take a look at the second explanatory variable. Suppose x2i measure the fertilizer that we used. Fertilizer used in the production process. And you have a third explanatory variable, which is x3i. Suppose this is the irrigation. This is the irrigation, right? Irrigation process that we have used. Now, whenever we talk of any regression situation, what we want to know? We want to know the cause-effect relationship. So we want to know how much the explanatory variables in our model. Explanatory variables are which variables? x1i, x2i, and x3i. These are the three explanatory variables of the regressors in this model. So basically, we want to know how much of the total variation of y is explained by these kind of explanatory variables in your model, right? This is the basic intention of running this kind of a regression. Now, what if I want to know only the effect of x1 on y? What if I want to know only the effect of HYV seeds on the yield of crop? That will be given by this particular thing, right? That will be intuitively, we can say that this is given by this particular coefficient. But the problem here is that if you think in this particular fashion, the problem is that within beta 1, you will be having a linear effect of all the rest of the two explanatory variables, right? If you think that if you want to find out the effect of x1i on yi, right? Effect of x1i on yi, then what will be the problem? The linear effect of x2i and the variable x3i will be reflected in terms of beta 1, right? The linear effect of the rest of the explanatory variables will also be reflected in beta 1. So what you have to do, you have to first eliminate the linear effect of all the rest of the explanatory variables so that you can find out the partial effect, so that you can find out the partial effect of one of the variables or one of the regressors on the dependent variable, right? So this is the concept. Now let me formally write everything for you. Multiple correlation. Start with multiple correlation. Multiple correlation is the joint effect, is the joint effect of x1i, x2i, and x3i on yi. So this will be the multiple correlation. In multiple correlation, what we do, we consider all these explanatory variables. We want to know the joint effect of all these explanatory variables. That will give us the multiple correlation. But what about the partial correlation? But if we want to test if we want to test the effect of only HYV seeds upon the yield of crops, eliminating the linear effect, of other variables, then we have to consider only the partial correlation, right? So this is the distinction between multiple correlation and partial correlation. So see, in case of multiple correlation, what we want to know, we want to figure out the joint effect of all the regressors that is present in the model, and we want to measure how much of the total variation is been explained by the regressors in our model. But in case of partial correlation, what we want to know the effect of only one regressor, particular regressor upon the dependent variable. Here it is yield of crops, eliminating the linear effect of all the other variables, and then that situation will be known as the partial correlation, right? Partial correlation. And in this video, I'll not going into formalization of that. I'll be doing that in the next video, how you can find that out, the expression. Here, I will only talk about the concept. So let's understand this concept with the help of this particular diagram. Suppose this rectangle here represents the total variation of the variable y, right? Y is the dependent variable which is yielding of crop. Suppose this entire rectangle represents the area of the total rectangle represents the total variation of y. Now this red circle here, suppose we assume that this red circle measures the effect of x1 on y. This green circle here measures the effect of x2 on y, and this blue circle here measures the effect of x3 on y, right? So here you have three circles. This rectangle represents the total variation. This red circle represents the effect of x1. Here you have the green circle represents the effect of x2, and the blue circle represents the effect of x3. Now let us call this particular segment as 1. Suppose this is 2, this is 3, this is 4, suppose this is 5, this is 6, this is 7. Now I want you to pause the video and think for yourself, in this diagram, what does this segment 1 represent? Can you tell me? Can you pause the video and think for yourself? What is this segment 1 representing in this entire diagram? Pause the video, think for yourself. You will be getting that it represents the only effect of x1 on y. This particular segment 1, it represents only the effect, a singular effect, only the effect of x1 on y. Now 2, the area 2, can you say what is this area? It will represent the joint effect of x1 and x2 on y. Area 2 will represent the joint effect. See, it is in the intersection of x1 and x2. So it will represent the joint effect of x1 and x2 on y. Now what about area 3? This particular area, it will be the joint effect of x1 and x3 on y. Now area 4, this will be the joint effect of x1, x2 and x3. See, it is in the intersection of all the three circles, area 4. So that will be the joint effect of x1, x2, and x3. So basically, this will represent the multiple correlation coefficient, multiple coefficient correlation. Then look at area number 5. What will be area number 5? If you see, it will be the joint effect of, this is the joint effect of x2 and x3 on y. Then you have area number 6, that will be only effect of x2. And finally, you have area number 7, that will be the only effect of x3, right? Only effect of x3. So here what we can say, 1, 6, and 7. Here see, you have the only effect of x1 on y. Here you have the only effect of x2 on y. Here you have the only effect of x3. Where you have the only effect, we assume that all the other variables are constant. They are not moving. Basically, we are taking the partial differentiation. In partial differentiation, what we say is that other variables are constant. We are changing one specific variable. That will give us the partial correlation coefficient. And here 0.2, 3, and 4, they 0.2, 3, 4, 5, they represent the joint effect of two variables, pairwise. Pairwise two variables. What will be the joint effect of that on y, right? So using this kind of a diagram, you can call it a Venn diagram. So using this kind of a diagram, you can clearly see what is the concept of multiple correlation and what is the concept of partial correlation. In partial, what we say is that we want to measure only the effect of one variable. So if you consider this first segment, here, what we are doing, we are only considering the effect of x1. X1 in our example is the HYV seed. See, it is the HYV seed. So if we only want to measure the effect of HYV seed, eliminating or removing all the other effects, then you will be getting this particular thing, right? I hope this is clear. Now, the next question is how to get the partial correlation coefficient. So suppose for that, we want to test, the effect of, say, take another variable. We want to take the effect of only irrigation, suppose. Irrigation is x3, basically, in our model. Irrigation upon the yield. So what we want to do, we basically want to get the net marginal effect. We want to get the net marginal effect of irrigation upon the yield, that is the net marginal effect of x3 on y, right? So how will we do that? For that, we have to think of a process. What is the process? So see, in the model, what we want to do, we want to find out the effect of irrigation on the yield of crop. This is what we want to do. But the problem, as I have explained before, that here in your model, you have two more variables, right? Here you have two more explanatory variables, namely x1 and x2. So what you have to do, you have to eliminate the linear effect of x1 and x2 from yi, and also eliminate the linear effect of x1 and x2 from this explanatory variable x3i, right? So the first step would be to eliminate, or say remove, the linear effect of x1 and x2 on yi, and second step would be remove the linear effect of x1, x2 on the explanatory variable that we are interested in, that is x3 or x3i. And then finally, what you have to do, regress yi on x3i. right? So this will be the process. Now let me show you how to do that. So first step would be the regression will look something like this. Suppose this is A naught plus A1 x1i plus A2 x2i plus say ui, or let me call it u1i. So this is the first regression. Now, if you suppose you fit this regression and you estimate the value of yi cap, right? Here, if you fit the model, you will get the predicted value of y, that is yi cap. Suppose E1i is yi minus yi cap. Now, can you tell me what this E1i represent? What does this E1i represent? It will represent the value of yi. It will represent the value of yi after removing the linear effect of x1 and x2. So what we are doing is that we are regressing yi on x1i and x2i. So this basically represents, if you predict this value yi cap, this value will give you the total variation of y, which is explained by these two variables, these two explanatory variables x1 and x2, which we don't need for finding out the effect of irrigation on yielding crop, right? So we basically need the effect of x3 on y for that to, get this effect, to segregate this effect from the other explanatory variable. We have to find out this particular thing. Now the second step would be to remove the effect of x1 and x2 from x3. So for that, you will run a similar regression. Beta 1 x1i plus beta 2 x2i plus say u2i. And from this model, what you have to do, you have to estimate x3i cap similar way, and this will give you E2i, which is simply x3i minus x3i cap, which is nothing but the value of x3i after removing the linear effect of x1 and x2. Right? So our first two steps are done. So we have removed the linear effect of x1, x2 on yi, and we have already removed the linear effect of x1, x2 on x3i. Now the last step would be to regress yi on x3i. So basically, what we have to do, we will use these two things, E1i and E2i, and finally we will regress them. So the third regression equation will look something like this. E1i. This is E1i. E1i is, suppose this is E naught plus E1, E2i plus some error term, which is U3i. And here, what we have to do, estimate this term, which is C1, E1, sorry, that will give you the partial effect of x3 on y or yi. In other words, in other way, we can write if you take the partial derivative of x3 upon this expected value of y given x1, x2, x3, or let me write in this way. This, then this will give you beta 3 cap, which basically means that the change in the independent, in the say the expected value of y due to change in x3, where x1 and x2 is assumed to be constant, right? So this was about the multiple correlation and the partial correlation. So let me go back to what we did today. So we started off with this kind of a model where we said that we have a dependent variable representing the yield of crop, and we have three explanatory variables, namely HYV seed, fertilizers used, and the irrigation. We have three explanatory variables. So firstly, we distinguish between what is multiple correlation and what is partial correlation. In this particular context, multiple correlation will be the joint effect of all the regressors on yi, whereas partial correlation will be the effect of one specific regressor on the dependent variable, keeping all the other variables constant, and that will give us the partial correlation. And in order to understand the concept, we have used this Venn diagram where we have said the rectangle represents the total variation and these individual circles represent the effect of individual variables. And we segregated out what is partial correlation coefficient and what is multiple correlation coefficient, right? And then we have intuitively discussed how to get the partial correlation coefficient, because multiple correlation is very simple to find. The problem is on the partial correlation coefficient, that is when you have to remove or you have to eliminate the linear effect of the other variables, other explanatory variables from the model in order to find the partial correlation of a specific regressor. For that, we have followed a three-step process. Firstly, we have removed the linear effect of other regressors on the dependent variable yi. Then we have removed the linear effect of these regressors on the variable that we are interested in. We want to find out the partial correlation of x3. That is why we have removed the linear effect of other regressors on x3 as well, and then we have regressed our dependent variable on or transformed dependent variable on the transformed independent variable. And this is the three-step process. This is the first regression that will eliminate the linear effect of x1, x2 on the value of yi. This is the second regression equation that removes the linear effect on x1, x2 on the value of x3, that is our variable of interest. And then we have run this kind of a regression. If you run this kind of a regression, the estimated value, we have to estimate E1 cap from here, this coefficient, and this will give us the partial effect of x3 on y. I hope you find this lecture helpful. If you have any doubts anywhere, you can let me know. And in the next video, I will formalize everything and we will see what is the relationship between simple correlation, partial correlation, and multiple correlation. And we will also derive the formula, how to derive them. So stay tuned for the next video, and thank you so much for your time. If you like this video, give me a thumbs up and do subscribe to this channel, AN Economist. Let's meet you in the next video. Thank you.